Hello folks, and welcome to Polynomials Unit 5. We are going to see that when we graph polynomials, they're going to look like cool roller coasters. So today we're going to start off by talking about the vocab that goes with it, how to do polynomial operations, and synthetic substitution. So let's get started on types of polynomials. So the first type of polynomial is called a monomial. A monomial has one term, and it can be a number, it can be a number and a variable, it can be a variable alone, but it's basically one term, one thing, nothing being added or subtracted to it. Now, in order for you to be considered a polynomial in the polynomial world, you would have to have an exponent that is a whole number. Okay, so exponents have to have they have to be whole numbers in order for you to consider it a polynomial. So this has to be a 0 or a 1 or a 2 or a 3. It cannot be a half and it cannot be a negative. And if you have an exponent that is a half or a negative, we would not call that a polynomial. So a one-term polynomial, a number, a variable, a number and a variable, but all whole number exponents. Two-term binomial has basically two of monomials put together, either by adding them or subtracting them. A trinomial is three monomials put together by either adding or subtracting them. Now, we don't have names for four-term polynomials, so anything over 4 and over, is just called a polynomial. Standard form. When I put a polynomial in standard form, I put the largest exponent first, and then I write all of them from largest to smallest. The degree of a polynomial is your largest exponent. So if your largest exponent is 6, x to the 6th is the degree. Here is a chart of all the degrees and types. We have a degree of 0 would be called a constant. A degree of 1 would be called a linear. Oh, wait a minute. We already learned linear, right? So how can we be learning about linears again? Well, a line is so important that it gets its own chapter. Just like degree of 2, we spent a whole chapter on quadratics. It's so important that it also gets its own chapter. Now, why are we learning about polynomials again? Because there's other polynomials besides linear and quadratic. So we learn linear, we learn quadratic, and now we're going to learn all the other ones, and they're just going to put them in one chapter. So if you have a degree of 3, that's a cubic. If you have a degree of 4, that's a quartic. If you have a degree of 5, we aren't going to talk about, you might see an x to the 5th, however, we're not going to name it anything. So these are the only names that you have to be aware of, okay? Otherwise, there is an x to the 5th, but I'm not going to make you know the name. There is an x to the 6th, that's also a polynomial, but I'm not going to make you know the name. Okay. This slide says decide if the function is a polynomial. If it is, then make sure you write it in standard form, state the degree, and the type and leading coefficient. So the first thing I got to look at is this a polynomial? Yes or no? Well, remember, a polynomial has whole number exponents. Whole number there, whole number there. So yes, it is a polynomial. Now, if it is a polynomial, I can write it in standard form. Standard form says take the largest exponent and write that one first. So this one's the first one, x to the 4th. Then the next largest, so that would be negative 1/4 x squared, and then plus 3. So now it's in standard form, largest exponent to smallest exponent, or no exponent. The degree is a 4. Because the largest exponent is a 4. The type, if you look on your chart, is called quartic. And the leading coefficient is the number right in front of the first term, which is a 1. Okay? Now let's do the second one. G of x equals 7x to the negative 2. Ooh, negative 2. That exponent is negative. Therefore, this is not a polynomial. So I will not answer these questions. Okay, now let's add and subtract polynomials. Find the sum or the difference. All right, in this case, we're finding the difference because they're being subtracted. Now, I'm not just subtracting the first term here. I'm subtracting this whole polynomial. So when I do that, I need to distribute that negative to each term. Negative times a negative is a positive. Negative times a negative is a positive. And now what we're going to do is put the things that look together and add them. Okay, so negative 2x cubed plus 2x cubed, that's going to cancel out. Now I'm going to look for all the x squareds. Oh, there's only one of them. And then I'm going to find all the numbers. Well, there's an 8 and there's a 4. So 8 and 4 make 12. And then I'm going to make sure that it's in standard form. Standard form says highest degree to lowest degree, or lowest exponent. The highest is 2, and there are no other ones. So this is in standard form. This would have a degree of 2, and what do we call that? Quadratic. Okay. And this would also be a binomial because there's 2 terms. Look at all those vocabulary words I'm using. I know, you're probably rolling your eyes. All right, so what is the summary of adding and subtracting polynomials? You need to add like terms. It's basically all it is. If you subtract, make sure you distribute your negative, but otherwise we are adding like terms. Multiplying polynomials. Multiply the following polynomials. Okay, if you had an Algebra 1 teacher that told you you couldn't use the word FOIL, this is why. We can't FOIL here. When we have a binomial and a trinomial and we're multiplying them together, we have to do what's called double distributing. So you need to take x times 7, x times 3x, okay, that would be 3x squared, x times negative x squared would be negative x cubed. Now we take 4 times 7, which is 28. 4 times 3, which is 12x. 4 times negative x would be negative 4x squared. Now we add all the like terms. But I'm going to make sure that it's in standard form as I do this, because that's the easiest way. So I'm going to find all the cubes. Oh, there's only one. I'm going to bring it down. Okay, I've used that up. Now I'm going to go squareds. Oh, there's a 3x squared. There's a negative 4x squared. That's negative x squared. And now I'm going to put the x's together. 7x and 12x make 19x. And last but not least, the plus 28. Now this is called the polynomial because we don't have for 4 terms, we don't have a name for it. It is going to be cubic. Okay, because it's a degree of 3. All right, and the leading coefficient is that negative 1. And that is in standard form. So when we multiply polynomials, we need to make sure that we use the distributive property or double distribute. All right, function notation. So what does it mean to be a function versus not a function? So this x squared plus 3x minus 4, that is not called a function, it's called an expression. The reason why it's an expression is because it doesn't have an equal sign. You can either simplify it, factor it, but you can never solve an expression. Okay, this is review. This next one is called an equation. Why is it called an equation? Because it has an equal sign. Okay? We use this when we want to graph or solve. And then this last one is called function notation, where we don't have this as a y anymore, but we have what's called a letter in front of an x. So we have f of x. Okay, this simply means the same thing as this. It's just a fancier way to write it. All right, there are two types of substitution, and we know how to do one. We know how to do direct substitution. That's the way you've been doing since Algebra 1, or maybe even before Algebra 1. But synthetic substitution is a new type that involves fewer operations and calculations than direct substitution. So let's review direct substitution, and then I'm going to teach you synthetic substitution. So direct substitution, what does that mean? Direct substitution is exactly what you've done every day so far this year. You have everywhere you see an X, you have plugged in a 3. So we have f of 3 equals 2 times 3 to the 4th minus 5, 3 to the 3rd minus 4 times 3 plus 8. Now, what you're going to do is you're going to take your handy dandy calculator out and you're going to figure this all out. So you're going to take 3 to the 4th because we do exponents first, PEMDAS. So 3 to the 4th is 81. So 2 times 81 minus 5 times 3 to the 3rd power is 27 minus 12 plus 8. And now we can just do this in our calculator. 2 times 81 minus 5 times 27 minus 12 plus 8 gives me a whopping 23 for a value. So that's what we call direct substitution. We've never used the word direct before, but that's what it means. Directly put it in your calculator. Okay? Now, synthetic substitution allows you to do many calculations without even using a calculator. So it's kind of a different little setup. So here's synthetic substitution. When we set it up so that our polynomial is in standard form, okay? And the only thing that we need are the coefficients out in front of the letters or the variables. So put it in standard form and then take the coefficients. So I'm going to take this 2 and I'm going to put it down here. Then I'm going to say, what is the coefficient in front of the x cubed? That's -5. What is the coefficient in front of the x squared? Yes, you have to account for every one. That's the trickiest part. If there is no x squared, you put a 0 there. And then what's the coefficient out in front of the x? That's a -4. And what is the number or the constant that doesn't have an x? That's an 8. Okay? Now, once you do that, then you kind of do this upside down division sign. Okay? I know I'm not very straight there, but that's what you do. You do kind of like an upside down division sign. And then what you are going to substitute, 3, goes outside here. Oops. Okay, so I put the 3 on the outside. Now, watch how I'm doing this. The very first thing is you bring down the 2. Then you take 2 times 3 and it gives you 6. That's a positive 6. Now add these 2 columns up, or this column up. That's a 1. Take 1 times 3. That's 3. Add this column up. 0 plus 3 is 3. 3 times 3 is 9. Add the column up. That's 5. Now take your 5 and multiply it to the number outside. That's 15. And 15 plus 8 is 23. Did we not just do this problem and use direct substitution and get a value of 23? We did. And this time we also got 23 using this form. And to me, this form is way easier. I didn't even need to take my calculator out. Last time, did you hear me? I had to take my calculator out. I had to figure out what those values were. So this is another way of substituting without using a lot of calculations, okay? Now sometimes you're going to have to use your calculator for it, I'm not going to lie, but sometimes they're so fast and easy you can actually find the value faster than you would directly. So let's do one more problem to make sure we know how to do this. Okay, we got to be careful with our setup. Remember, we have to make sure that we always use every value. So if the largest degree is, if the degree is x to the fourth, that's the largest exponent, then you have to make sure that you account for every single x from 4 down. Okay, you don't have to worry about x to the fifth because we didn't even have an x fifth here. But you always find your largest exponent and then you have to account for everyone below that. You do your upside down, kind of a division sign, and then you put your exponent, what's in front of your exponent, your coefficient, underneath. So here I would have -2. Here I would have -1. I don't have an x squared, so it's 0. I would have a 4 for my x, and I would have a -5 here. Okay, and I'm just always saying be careful with your setup because you always want to make sure that you account for every x from the largest down to nothing. Now we are going to evaluate when x is -1, so I'm going to put a -1 out in front. Okay, same process. Oops, sorry. Bring the -2 down. -2 times -1 is 2. Add the column, which would be 1. Multiply it by the outside number. Add the column. Multiply it to the outside number. Add the column. Multiply to the outside number. Add the column. Now when you get here, that is your answer. G of x, or I should say, G of -1 would equal -10. Oops. Make sure I get that negative in there. Okay, so G of -1, it's kind of hard to read. Let me erase that. It's not going to let me here. Okay, so G of -1 would be -10. Now, if you wanted to, you could use direct substitution. Substitute that -1 in for everywhere you see. 2 times -1 to the fourth minus -1 cubed plus 4 times -1 minus 5. And hopefully, when you put that in your calculator, you would also get -10. Okay? All right, that is it, and we will see you tomorrow.